Okay, last time we started with the topic of traffic components. There are 5 components: road users, vehicles, streets and highways, traffic control devices, and the environment. Okay, and the road users, the most important ones are the drivers. Okay, because they are driving the vehicles, obviously. And even if the vehicles are automated, they are designed according to driver behavior, because you need to consider how others will be expecting the vehicle to move. Okay, they are expecting it according to how a driver will do it. Okay. Now, in driver characteristics, our job is to give the information to the driver clearly, so that he can get the information and act according to the information in a timely manner, okay, on the right time. To get the information, most of the information is taken by our eyes, okay. So these are different functions of our eyes which we use during the driving, okay. So I explained it in the last lecture, and the examples are also, their explanation samples are also given here. Okay, if I'm looking at you, okay, and there's somebody on the window, there's something on the window, okay, which of these characteristics will help me see that there is something on the window? I'm looking at you, okay, yes, there's someone who is waving from the window to me, doing like this from there. So which of them will help me see that he is waving from the window? Which of them?
Static visual.
Mm-hmm.
Static visual.
No. Static works when you are looking directly at the thing. I'm looking at you, but that person is on the side. So which one of them will help me look at the thing from the side, or detect something from the side? It's near the end of the table. Near the end of the table. Which one?
Peripheral vision.
Yes. Peripheral vision. Okay. Peripheral vision. You are looking straight and something on the side, then you need your peripheral vision to detect that. Okay. Now what about if something is coming towards me? Okay. If something is coming towards me, somebody throws something at me, maybe a football or something, okay, and I have to get out, otherwise it will hit me. Okay. So how would I know that how far is this thing and how fast is it coming? Which one of these abilities will help me know that something is coming right at me, okay, and I have to see how far is it and how fast is it? So which one of these will help me do that? There are 2 of them actually, not one. 2 of them which will help you with this case. Something coming towards you and you want to know how far is it and how fast is it. Yes, movement in depth, okay, and the other one is also depth perception. Movement in depth helps you detect the speed, and depth perception helps you detect the distance. Okay, clear? Okay, and these things are used during the driving as well. Okay, our vision is mainly where we are looking at, right? Okay, when you go for the eye test, they will put a board in front of you, right? And they will say, okay, read from it. This is how they do the eye test, right? So you have to look at the board, right? Somebody is looking like this. They will not ask him to read the book. He cannot read, right? So your vision is where you are looking at. Okay. From the point where you are looking, your range of vision is divided into 3 categories. Okay. This is from the point where you are looking. From this point onwards, your vision is divided into 3 categories. Okay. So this is my 0. I'm looking here. This is my 0. Okay. From this 0, my vision is divided into 3 ranges: acute vision, fairly clear vision, and peripheral vision. Okay. From this line of sight, my vision is divided into 3 ranges: acute, fairly clear, and peripheral. Okay. Acute is the best range. Okay. So if this is my 0, from this 3 to 10 degrees. It varies from person to person and according to their abilities. Some people have less range and some people have more range. Okay. But it is between 3 to 10 degrees. You will see that in all the 3 cases. They give us a range, not a value. Okay. Because it varies from person to person. Okay. So the minimum which anybody can have is 3 degrees. The maximum which anybody does have is 10 degrees. This is for the acute vision. Okay, and is considered the best one. Okay, not acute vision. Acute vision is also the best, but this is with an A, acute vision. Okay, why it is the best? It is the best for reading and comprehension. Okay, if you want to analyze the distance, the color, the shape, the words, the text, the symbols, anything which is in this range gives you the best chance of reading it. Got it? Okay. The next one is fairly clear. So see, acute was up to 10 degrees, right? Fairly clear is only little bit ahead of it, up to 12. Okay, so it's very close to acute vision. So there is not much difference between acute and fairly clear. There is a very small difference. Okay, in acute vision and fairly clear, there is a very small difference. So most of the things which you can do with acute vision can also be done with fairly clear vision. Okay, the changes are very minor. The changes are very minor. Maybe you cannot look at very minor details, but most of the things are very clear, even up to this range. Okay, and then you go to the extreme, which is after 12 degrees. You go to the extreme. This is called as peripheral vision, and the main function of peripheral vision is detection, not comprehension. Peripheral vision is for detection, not comprehension. Okay. So what is the difference between comprehension and detection? If I ask you to read something, this is comprehension. Reading something is comprehension. You have to look at it, right? Okay. But if I ask you, is there a wall on the side? You can tell me yes, there is a wall. You don't have to actually move like this. Okay. You can detect yes, there is a wall. Okay. Is there a chair here? Yes, there is a chair. But if you ask me something is written on the chair, I will have to look like this, right? I have to look at the chair. What my point? Okay, if you ask me how many screws are in the chair, I have to look at it and count, right? This is called comprehension. For comprehension, you should be in the first 2 values, first 2 ranges, up to fairly clear. Okay, but if you ask me, is there a chair on your side? Yes, there is a chair, yes. Even without looking at the chair, I can detect, because this is in my peripheral vision. Right? Clear? Now, in terms of traffic signs and markings, in which range should these markings and signs be? The traffic signals, the traffic signs. In which range they should be? We have 3 possible, right, answers. Which range is good enough for traffic signs and markings and signals? Fairly clear. Okay, but I say up to fairly clear vision, most of the things are enough. You can read them, you can comprehend them, and so on. So any traffic sign, any traffic marking which is up to fairly clear range is enough for me as a driver to see and get the information. Got it? Okay, for receiving the information, fairly clear is enough. Okay, what is the purpose of peripheral vision? Peripheral vision mainly helps you decide your speed. You decide your speed using peripheral vision. Okay? So if the road is clear in front of you, if you remember the equations which you have used for finding out free flow speed, in those equations there was a factor for lead width, there is a factor for lateral clearance, there was a factor for median, there is a factor for ramps, factor for access points. Now where are these things? Lateral clearance is where? On the side. Median is where? On the side, right? Where is the ramp? On the side. So why are we using these things for speed? Will I drive on the median? Will I drive on the median? No. So why am I using the factor for median? Will I drive on the lateral clearance on the side of the road? No. I will drive on the road itself, right? Okay. But these things are in my peripheral vision. If there is a median, I will see it in my peripheral vision. So my driving speed will be different because there is a median. If you remove the median, my speed will change because now I don't see the object in my peripheral vision. Got my point? So if you keep the same road for me, same traffic condition, okay, but in one case the road is larger, wider, in the other case the road is narrow. If all the things are same, the narrow road will have less speed from me because of my peripheral vision. Okay, I will feel that I am restricted. If you make the road bigger, even if the straight is the same, I will go at faster speed. Clear? Okay. So this is the role of peripheral vision. Okay, timing is also very important. Timing is also very important because on the road you are moving, right? Okay, so timing is very important. At what time you will get the information. Now you see in this condition, when the car is here, and you look at the traffic sign. If I am looking at the road, the sign is here. Okay, I am looking here with the blue line. This is my line of sight, and where is the sign? Here. It's in my acute vision, right? It's in my acute vision, so I should not have any problem at this time. Look at the sign and read it. Okay. If I miss the sign here and I go forward, now you see my angle has changed. Okay. So when I was here, I was looking at my phone. So I missed the sign. I go forward to look at the sign and to read the speed. Now I have to change my line of sight. Okay. So timing is very important. That's why they say if you just have a look at the screen of the phone, for like just look at it and look up on the road again. Just by doing this, you increase your chance of crashes by many times because you have missed the information. Okay, you are supposed to see something now, and by looking at it, you have missed it. So when you are doing this, you already crossed 50 meters to 60 meters. Okay. So now that thing which you have missed now will be already in front of you. Okay, or it's very close to you. Got it? Clear? Okay, so timing is very important, and now we come towards the other part of driver characteristics, which is the perception reaction process. Okay, perception reaction process means now you will decide what to do. You will decide what to do for the information. This perception reaction process has 4 steps. It has 4 steps. The first step you already covered. You look at something. Okay? That looking is called as detection or perception. I looked at something. Any object, any person, any vehicle, anything. Okay? That is called as detection and perception. Then the next step is I will see what situation I am in. What is my condition? What is condition of the object which I looked at? This is called as identification. Okay? Analyzing the situation. Third one is deciding what to do. Third one is deciding what to do. And the last one is doing the action. Okay? So looking, analyzing, deciding, acting. Right? Okay? So you look at a person on the side of the road. First step. Now you look at your speed and you look at the person, you look at the distance. Second step. Third step, now you decide what to do. Okay? Slow down, go faster, brake, completely stop, what? I have to stop, where should I stop? Last step, you do what you have decided. Clear? Okay? So you decided you will push the brake, pushing the brake will be the last step. Okay? And this should give you an idea. So I looked at the signal, first step. I am looking at my speed and the distance and the sign of the signal, the light of the signal, second step. Third step, I am deciding what to do. And the last step, I push the brake. Okay? Clear? Now when you push the brake, so you can see the position of the car, right? When he is pushing the brake, you can see the position of the car. Will the car stop here? When you push the brake, will the car stop here at this point? No. Okay, this is not part of perception reaction process. The extra distance the car will cover after pushing the brake is not part of perception reaction process. Because I already did my action, right? My action is done. Okay, so when my action is done, my perception reaction process ended. Okay, the later is something else. Clear? Okay. And obviously this does not happen step by step, it happens very fast, right? One after another. There is no gap. Okay, I'm just having a gap to explain to you. Okay, some values of perception reaction times which they have found from different studies. Okay, the first one is for signals. I mentioned at the end of the last chapter as well, is 1 second. For signal, the perception reaction time is 1 second. For normal stopping on a highway, it is 2.5 seconds. Normal stopping means that you have a traffic jam, or you have a check post, or you have a stop sign. This is normal, right? Roundabout. This is normal. So for this we have 2.5 seconds. So these two are normal. The first two things are normal. The other ones are called avoidance. So something unexpected happened, you were not expecting it. Okay, somebody suddenly came in front of you, somebody stopped, a child came on the road, something. Okay, so this is anything unexpected comes under the other categories, avoidance categories. Okay, now what are we avoiding? We are avoiding the accident. That's why I call them avoidance methods. Avoiding accidents. Okay, now you can see which time is higher, the normal one or the avoidance one? Which time is higher? Normal or avoidance? Avoidance is higher, right? And what is the difference between them? What is the difference between normal and avoidance? What is the main difference? When we say something is normal, that means what? Happens? Normal, all the time, right? Okay. And this is unexpected. Okay, so this one is expected, this is unexpected. So what do we say? Something unexpected needs more time. Something unexpected needs more perception reaction time. Something which is expected, it needs less time because your brain already knows what to do. What my point? Okay? Then, now you are trying to avoid something unexpected happened, you are trying to avoid an accident. To avoid an accident, you may stop. Okay? You may go in the other lane. You may reduce your speed. You may take a turn. All these things are possible, right? Okay. So you see avoidance for stopping and avoidance for other things. Okay. Clear? Now you can see these two. This is stop. This is stop. Avoidance, avoidance. Okay. What is the difference between them? This is on a highway and this is on an urban road. Okay. Now which one will have more traffic? Highway or the urban road? Which one will have more traffic? Highway or the urban road? Highway. More traffic. Urban road. Because it has more population, right? There are more people living. More. Highway means it's outside the city. It's outside the city, so there is the traffic. Okay? So urban roads have more traffic and more population. Okay? So now you see which time is higher? Highway or the urban road? Urban road is higher, right? So it's higher because of more objects. Traffic is what? Objects, right? Every vehicle is what to me as a driver? It's an object. Every person is what? It's an object. Every building is what? object. Okay, so more objects or more information needs more time. Got it? Okay, and again, this is a study which they have done. When you look at your window screen once, you see more than a million things. More than a million things. One glance, one glance, one look. Okay, in one look, your eyes can see more than a million things. Literally, like this is a number. Okay, and then your brain decides out of all these things which one should I focus on. Okay, where? You look at all the things, there's the car, there's the pedestrian, there's the kid, there's the light pole and so on, and there's the flight. So you have to decide, your mind will decide, should I look at the kid or should I look at the flight? Or should I fly? Whatever. Okay? I had a friend, he had an accident once. Okay? He went to the hospital, the car went into police, and then he took him back. And I asked him what happened. He said, there was a fly in the car. There was a fly in the car. Okay, so, and then he don't tell anyone. So you see, I keep my promise. Okay? But you get the point. Okay, the point is more information, more time. So there are two things which we can detect from these values. The first thing is about expected and unexpected. Which one needs more time? Unexpected. Okay. And the other point is about more and less information. Okay. More information needs more time. Clear? Okay. We already mentioned about expected and unexpected. Expected things come under three categories. Expected things or expected information or expected events come under three categories. Okay, what are these categories? Continuity, event, temporal. Continuity, event, temporal. Okay, continuity expectancy is expecting the things of the immediate past to continue. Expecting the things of the immediate past to continue. For example, the car in front of you which is moving, you expect what? It will keep on moving. The car in the other lane, you will expect that it will keep on moving in the other lane. Okay. Most of the crashes are because of this violation of this expectancy. The car stops suddenly. The car comes in your lane or goes from your lane suddenly. Okay. So all these are violation of continuity. These accidents happen because of violation of continuity. Okay. Event is the opposite of continuity. Event is the opposite of continuity. Continuity was what? Something has happened, it will continue. Event is something has not happened, it will not happen. Okay. Something which has not happened, it will not happen. Okay. So when people come to me, I want an A grade, they should go and look at the transcript. Right? Something which has not happened will not happen. It's written. Okay? Clear? But for example, there is a highway and there is no pedestrian crossing, there is no crosswalk. You have not never seen a pedestrian to cross on this road. So next time you are not expecting anybody to cross. Clear? Okay? Or when you come to this road, there is no speed hump. So you expect there will not be any speed hump this time. Okay. So you may have seen when they change the speed limit, when they put a new signal, when they put a new, or even I have seen when they change the signal timing. They put a board for some days before the signal or before that point that we have made this change on this point. Expect a change in speed, or expect a new signal, or expect a change in signal time. So that this does not happen to you. Okay? You are imagining there is no signal, but now there is a signal. Got it? Clear? The last one is temporal expectancy, meaning expecting things to change according to a cycle, according to a pattern. Okay, so for example, a traffic jam. Okay, so I know this is the peak hour. I know the pattern. This is the peak hour. So in this hour, I am expecting that yes, I will go slowly on this road. Before, I know this is not the peak hour. Okay, so I am expecting myself to go faster. Got it? Okay, so I am expecting things to change, but according to the same pattern which I have seen earlier. Got the point? Okay, so I am not expecting that I will always go fast on this road. I am not expecting that I will always have traffic jam on this road. I am expecting both things, going fast as well as traffic jam, but at different times. Right? Okay, and the example is the signal. Signal, there are three lights, right? Okay, when you come towards a signal, if you see red, I know after red it should be which one? Yellow, right? So I am expecting it to change, right? I am not expecting continuity. I am not expecting event. I am expecting a change, but in a cycle. Okay, yellow and sorry, red and then yellow and then green and so on. Okay, and I am also expecting the timing as well. Okay, I know green will be longer, yellow will be shorter, red will be forever, right? So things like this. So this is cyclic, this is temporal. Okay, another important road user is the pedestrians. Pedestrians are obviously very important and part of the road, and they are also very vulnerable as well. They are at higher risk in terms of accidents. Okay, so they are involved in many serious accidents, accidents which involve deaths and serious injuries, and you can imagine the reason. Okay, because you are directly hitting the pedestrian. There is no airbag, there is no seat belt, no protection, right? Okay, so the pedestrian is hit, the chances of injury and death is very high. Okay, and this has been seen around the world as well as in Bahrain as well. Okay, if you follow or if you have looked at the news about traffic accidents, you will find that every second or third accident which has a pedestrian involved, it is very serious. Okay, not even every second or third. Every accident which involves a pedestrian, it is very serious. Okay, if you just look at the news from last 2-3 months, you will see that. Okay, and another problem with that is those pedestrians are normally in the young age interval. Okay, the pedestrians which are involved in accidents, they are very young, less than 20, even less than 10 as well. Okay, so this is another problem because it's, a guy who is less than 20, he has a lot of years in front of him. Okay, so if he gets into an accident, there is a life. Maybe if he gets disabled, he is disabled for the next 40-50 years. Okay, so some values are given here if you want to design a pedestrian signal. Okay, and we have used it in the end of the last chapter as well. These the same values for checking the timing of the signal. Okay, you want to design a pedestrian signal or you want to check the timing of the signal on an intersection, you need the pedestrian speed. How fast they will cross, and using the width of the road, you can calculate the time. Okay, so the speed of the pedestrians is given here, the recommended speed. Starts from 4 feet per second, which is considered on the higher side. So if the pedestrians are fit and normal and everything, you can take up to 4 feet per second. Okay, but if most of the pedestrians are old and they need help to move, then the lowest value is 3 feet per second. Okay, and these values are given by MUTCD, Manual on Uniform Traffic Control Devices. Some other devices which we use for pedestrian crossing. Okay, so you may have seen that wherever there's a crossing, they make the crosswalk down at the floor level, at the ground, at the road level. Okay, so if somebody is in a wheelchair, they are using a stick, they don't have to go up and down. Okay, they are at the road level, same level as the road. Okay, another thing which you can see here, this type of a speed hump. It goes like this, like a trapezoid. Okay, this is called as pelican crossing. Okay, pelican crossing, which is for pedestrians mainly. Okay, it's like a speed hump. And then you can see the barriers at the end as well. Okay, so nobody can block this way. So when you are crossing, now you reach the end and there is something blocking you. Now you cannot cross. You are on the road. So they put barriers like this, so there is nothing on the side. When you cross, you will cross and you reach the other side. Another important part of the traffic system is the vehicles. Okay, so ASHTO has divided the vehicles into 5 types. Okay, ASHTO has divided the vehicles into 5 types. And what is ASHTO? Who is ASHTO? Huh?
System.
System for soil, right? Classification of soil, right? ASHTO is a system for classification of soil.
No, not for soil.
Not for soil.
This one for the traffic.
This one for the traffic.
Yeah, it's depends.
It depends.
But it's a classification
It is
system.
also for soil.
But at the end, it's a classification system.
In the
I'm
end,
sure.
it's a classification.
It's unsure.
Huh? Sorry? See, every class, everybody has a new answer.
No, but
And just imagine all of you are wrong.
I'm pretty sure. No, I'm pretty sure this is the ASHTO. It's a classification system for.
And
And
I'm damn sure you are wrong.
No,
Yes.
I'm gonna say.
Yes.
There is like an actual there for soil and for traffic. and
Yeah.
for everything there's.
But it's a classification system.
Yes.
It's true.
No.
Okay, what is the truth? Tell me.
But, oh, no. This will come in the exam.
So it's coming for the
Yeah,
exam.
yeah.
So you have to tell me what is the truth.
No, I don't know.
No, you have.
Why?
You are
Because you
addicted.
are going up to.
Huh?
You are addicted. Must be.
You are
No, you already
teaching.
know it. You already know it.
But
Everybody
it
knows
will
it.
be I'm wrong.
Huh?
Until I prove that I'm wrong.
But
Tell me your answer.
all of you have an answer, right? Same thing happens in the exam. All of you write an answer, even if I explained it in the class. You write the wrong answer. Okay? So at least you are doing it on your own. I'm not involved. Somebody told you about ASHTO, right? And you forgot. Why should I tell you again?
Also in the water supply there is actually.
Or see? Now it's in the water supply as well.
I'm scared.
Very soon it will come in physics and chemistry as well. By next semester it will come in physics and chemistry. Yes, it's a classification system for differential equation. I'm sure.
Okay, Victor, what's the
What?
right answer?
American ASHTO.
American
Static
ASHTO, see?
highway
And then the British
transportation. Okay.
What? Okay.
Provide use of standard. Okay, standards. It's the same. It's
It's
really
the
the
same.
same at the end.
Okay.
Be the soil or not?
Be the story in January. That was one of them for traffic.
Traffic like what? Like traffic like soil.
See, if you come in the exam, you will give wrong answers, I will give you 0. You will go for the low, it will go to another teacher and you will keep my 0. And then you will know that it was wrong. Okay. So according to ASHTO, vehicles are divided into 5 categories.
It's
But
not in a classification.
yes,
Okay, I told you the right answer from the
no,
beginning.
it's not the right answer. It says classification of vehicles
A
by ASHTO.
classification
ASHTO
of
is not
ASHTO.
classification system.
ASHTO, okay.
ASHTO is not classification system.
Okay, it's fine. Yeah.
Yes.
It's very nice.
Huh? What's ASHTO? What's ASHTO?
I don't know.
Read it.
I will.
Read it.
I already told.
Forget about this one. Read it. What did you search?
English in what?
What did you search? What did it say?
I
AASHTO. What does it mean?
You
AASH.
didn't say what is ASHTO mean. You said what is ASHTO mean. For what we use ASHTO.
No, I didn't say this.
So you mean what is ASHTO mean?
I am
Yeah,
saying
you
what is
mean
ASHTO.
ASHTO.
What is
Okay.
ASHTO?
Okay, I will tell you.
And it was at Ashton?
American Association of State Highway and Transportation.
Officials.
Okay.
Officials.
Okay.
They are people It's not a system. There are people who are doing this. Those poor people think that you think that they are a system or classification and what. They have a society, they are people. Imagine somebody told you that University of Bahrain is a system. Like we are working. Okay? So, anyways, talk about soil classification. Soil classification is unified soil classification system and other soil classification system. So if you say UCS, it's a classification system only, it has nothing else. Okay, ASHTO is a body, it is an organization, and for some weird reason they did the classification as well, and they are famous for that, but they are not doing only the classification. Their job is not classification. Okay, they are not the classification system. They just did something and it is famous by their name. Anyways, according to ASHTO, vehicles are classified into 5 categories. Okay, in the previous chapters when you were doing highway capacity analysis, in the previous chapter when we were doing highway capacity analysis, we only divided the vehicles into 2 categories. We only divided the vehicles into 2 categories. First one was passenger cars. Okay, and what was the other type? The vehicles in the previous chapter were divided into 2 types. Passenger cars and what else? Heavy vehicles. So all of them are heavy vehicles. Okay, all of them are heavy vehicles. Why we have more types? Now because we are talking about road design. So for road design, we do not follow the 2 types. Okay, for road design, we divide them into more types because it has to be more detailed. Okay, if you consider all heavy vehicles as one type, it will not be good for the design of the road. Okay, so that's why we have different types or more types of vehicles. Again, from the point of view of road design, so everything is now according to road design. From the point of view of road design, there are 4 things about the vehicle which are important in road design. Their braking means deceleration, right? You are decelerating. Their acceleration, their low speed turn and their high speed turn. Okay? There are 4 things about the vehicles which are important for road design. Their braking, their acceleration, their low speed turn and their high speed. Okay? And all these 4 things are affected by the weight and size of the vehicle. All these 4 things are affected by the weight and size of the vehicle. Okay? For example, if the vehicle is bigger and heavier, what will happen to its acceleration and deceleration?
It will be
More or less?
less.
Less. Okay? So to get to more speed, they need more time, right?
Yes.
Vehicle is bigger and heavier, it needs more time. Okay? What about turning? If the vehicle is bigger and heavier, what will happen to its turning? It will not time.
Space.
Space. It will affect the space. How much space they need. Okay? So basically it affects the time and the space both, but in different cases. Okay? Clear? There's another thing as well which affects these characteristics, which is the operating characteristics. Okay? So if I give the example of an airplane and a truck. Okay? An airplane and a truck. Okay? Which one is heavier? Airplane is heavier. Which one is bigger? Airplane is bigger. Which one is faster? Airplane is faster. But what did we say just now? If it is bigger and heavier, it should be slower, right? Okay, so why airplane is faster with all the extra weight and size? Because of the engine basically. Okay, it has an engine which can carry the extra weight and load at faster speed. Got my point? Okay, so vehicles which are heavier and bigger can still be faster and they can still make the turns with low space if the operating characteristics allow it. Clear? Okay. We have many vehicles which move on the road at the same time. For design, we have to pick one of them as the design vehicle. that vehicle should be what? Which vehicle should be picked as for our design? If I see 10 different types of vehicles,
The heaviest.
the heaviest one, right? The heaviest one will need more time, more space and so on. Clear? But are all roads designed for the same heaviest vehicle?
No.
No. So we have to look at what is the heaviest vehicle, which heaviest vehicle?
Which is the question?
There is a heaviest vehicle, right? But all roads are not designed for this vehicle.
Yes.
Some of them are designed for some other vehicle.
Yes.
Why not this one? Because
We don't need vehicle in this area.
yeah, this vehicle does not have enough frequency in this on this road. Okay, so you have to look at the frequency as well. Okay, you have to look at the frequency as well. How often this vehicle will come on the road? Okay, so the road which is the Zalak highway is not designed for the same vehicle as the street we have on inside the campus. The road outside the campus is not designed for the same vehicle as the road inside the campus because we are not expecting the same vehicle inside. Got my point?
Yes.
Okay. In some cases, we do not take the heaviest vehicle off the road as well as our design vehicle. If its frequency is low, okay, if there is a heaviest vehicle and we are expecting it on the road, but we are expecting it very rarely, okay, the chance of this vehicle coming on the road are very low. There is a chance, but it's very low, so we can ignore it. Okay, and how much we can ignore? We should try to cover 95% of the traffic. So anything which covers 95%, I will take it. Okay. Anything which is more than 95%, okay, I can ignore it if the other 95% are covered. For example, I have two trucks. One of them is expected 6% of the times. Another one is expected 1% of the time. Okay. Now, if you ignore the truck with 6%, you cannot cover 95%, right?
Yes.
If you ignore 6%, you cannot cover 95%. You will only cover 94, right? What am I? If you ignore the truck, which is only 1% of the time, you are covering the remaining 99%, right? Remaining 99% is covered. What am I? Okay. Why don't we always go for the highest one? Because of the cost. Okay. Just to cover one more extra percent, I will have to increase my pavement thickness. I have to increase my road space as well. It will take a lot of cost just for 1% traffic. Okay. So if the traffic expectation is very low, we ignore it and design for the remaining. Clear? Okay. Some guidelines are given. The minimum design standard for any road is a single unit truck, which is the same size as an emergency vehicle. What is an emergency vehicle? Which one is called an emergency vehicle? Ambulance, fire trucks, okay, dump trucks even. These are all emergency vehicles. Okay. This is the minimum. Parking lots can be designed for cars. Parking lots can be designed for size of a car. Okay. Parking lots are not designed for emergency vehicles. Okay. So if there is an emergency, where will the emergency vehicle go? If there is an emergency in the building, yeah, on the road? No. There is an emergency. There is a mall.
Okay.
There is a mall, and something happened inside the mall. The fire truck is coming. Should the fire truck go inside the parking?
No.
No. It should go where? Directly to the front gate. Okay. So you need an direct access road to the front gate. Okay. You will not design the parking lot for the emergency vehicle. You will design a road which will come from the main road directly to the gate for the emergency vehicle. Got my point?
Yes.
Okay. According to the size of the vehicle, you will decide your lane width, right? Vehicle is bigger, you need more space. Clear? This much is clear? Also, your turning and something which we call as lane widening. The lane width on the straight road is less than the lane width on the turn. Okay? The lane width on the straight road is less than the lane width on the turn. The turn has bigger lane width, larger lane width. Why? Because of the heavy vehicles, because of the large vehicles. Large vehicles cannot make a turn in a circular way. They need more space. Okay, everybody got this point? Okay, so this factor is called as lane widening. Okay, the normal lane width goes up to 3.5 meters. In Bahrain, we use more space because we have lots of space, like the whole sea is available to us. Okay, so on and so forth. Okay. Turning characteristics can be divided into two types: low speed turn and high speed turn. Okay, what is the difference between them? This limit. The difference between low speed and high speed is 10 miles per hour, which is around 16 kilometers per hour. So anything less than that is low speed, anything more than that is high speed. What is the difference between them? The effect of external forces. When the car is moving, it has air resistance, it has weight, it has friction, and so on. Okay? If the car is moving slowly, these external resistance will be less. If the car moves faster, the external resistance will be more. Okay? Clear or not? People who are into jogging and running and so on. Same thing happens there as well. You try to increase your speed, you will have to push more, right? Okay? Why? Because you have more resistance now from the outside. If you walk by like me, you will live peacefully and die peacefully as well. No problem. Okay, clear? Okay? So something you have to keep in mind for your life as well. If you face more resistance, that means you are going faster. Okay? If you face more resistance, that means you are going faster. Okay? So, if the external forces are less, their effect is almost negligible. You can almost cancel it, ignore it, and then the turning is according to the size of the vehicle. The turning is only according to the size of the vehicle. It's just like I'm turning this. Okay? So I need this much space, which is my arm. Okay? Clear? Okay? There is no speed. I can turn like this, no problem. This will give you an idea. So low speed turn is normally on the intersection. On the intersection you come, you stop, and then you make the turn, right? So your speed is very low. If your road has a curve, if the highway has a curve, then you are already at 100 kilometers per hour. So you don't stop, you will just continue, right? So this is high speed turn. If you are having low speed turn, you can design the turn according to the size of the vehicle. So you can see the size of the vehicle is given in the first column. Then you can see the radius of the road and the radius of the inside curve. Radius of the road means the center line. Center line. Radius of center line. And this is the radius of the inside edge of the road. Okay. Their difference will give me what? This is center line. And this is inside edge. If I take the difference, I will have what? This gives me which value? I'm not asking for the value. I'm not asking for the number. But if I take the difference between the center line and the inside edge, what will I get? This is center line and this is the inside edge, right? If I take the difference, what do we call it? What do we call this? This is the width, right?
Yeah.
This is the width. Okay. So I told you about lane widening, right?
Yeah.
That for turning you have to widen the lane. So that's why two values are given. So you know how much extra width you have to give. Got my point?
So
that's why two values are given. Yeah, it's like half of the width. Okay. So you can see as the size is increasing, the radius is increasing, more space, right? And if you look at the difference is also increasing, means more width. So you need more radius and you need more width. Okay? So if you look at the width here, from here to here, less than 10, right? What is the difference? Less than 10. And if you look here, more than 20. Okay? So this is because the vehicle is now increasing. So you need more width as well. Okay? So you need more turning radius and you need more width. Clear? Okay? Any questions?
No.
when you are making the turn, okay, I'll finish it fast, only 2 slides here. When you are making the turn at high speed, then you have to balance the extra forces acting on the vehicle, the external forces acting on the vehicle with the radius and super elevation. Okay, what is super elevation? The tilting of the road, the cross slope of the road. Okay, super elevation is the cross slope of the road. So you will control the external forces with the cross slope and with the radius. Okay, this is the main equation and this is the final equation. Okay, in the main equation you are trying to balance these two sides. Okay, this is in percentage, so fraction. This is a coefficient, so fraction. Fraction multiplied by fraction, almost 0. So this will be cancelled out. You cancel out this one, r on one side, everything else on the other side, you will get this equation. Okay, why do we have 15 here? 15 is the conversion factor and the gravitational force. Okay, 15 is because of the conversion factor and the gravitational force. What are we converting? The speed. The speed is in miles per hour, we are converting it to feet per second. Okay, same thing here. This is in meters. So the speed is in kilometers per hour. I am converting into meter per second. Clear? Okay. And the last thing are the recommended values for E and F. E, or the cross slope of the road, minimum is 0.5%. Or anyway, cross slope of the road should be at least 0.5%. Why? For bridge, for passing of the water. Okay. You can go as high as 12% for normal conditions and up to 8% for wet conditions. Up to 12% for normal, up to 8% for wet conditions. Why less for wet conditions? To avoid slipping. If the road is wet and the slope is very high, there is chance that the vehicle may slip. Okay, and when we say wet conditions, I mean most of the year. So if you have rain one day in the whole year, you will not change your value. Most of the year is dry. Got my point? Okay. Yeah, and this is the table for coefficient of side friction, the F value. Okay, and you can see the F value depends upon speed. The speed increases, F value. The speed is increasing, the F value is decreasing. Okay? Okay. So radius, speed, super elevation, coefficient of side friction. Clear? Any questions?